good afternoon. As you can see from the title slide, this is a presentation about standards by a civil servant, which probably explains why it's last on the agenda. And what we're going to talk about is something of a divergence from what we've talked about so far today in this section, and it's really addressing the lack of a data infrastructure in the engineering sector and the engineering materials sector specifically. First of all, I'll go over the role of the JRC in the European Commission, then some details about what characterises the engineering materials sector. Some things it has in common with life sciences, some things it doesn't. But there should be resonance as far as some of the common issues is concerned. Then the prenormative research, which is really the focus of the presentation, and two projects that we've performed in the past and the last one's ongoing about developing standards compliant data formats. Okay, the Joint Research Centre is basically a directorate in the European Commission. It's the only directorate which is not policy-based. We deliver scientific and technical support to the policy directorates. So we help throughout the policy life cycle, from the initiation to the establishment of its impact at the end of the policy life cycle. This is a structure of basically the European institutions. The European Commission is the European Civil Service, and there are various departments or directorates, and the JRC is affiliated with the Research Directorate, and there are a number of institutes which make up the JRC. And as mentioned before, what we're supposed to do is deliver evidence-based scientific and technical support throughout the whole policy life cycle. As I mentioned already, we work closely with the policy directorates, and we work in a range of different areas which are presently of interest to the European community, extending from environment through industry, and also more recently financial services. There are 7 institutes within the JRC. Conveniently for me, I work at the Institute for Energy and Transport, which is about 40 kilometres north of Amsterdam, so it's easy to get to today. And the work that we undertake, the mandate for the work that we do at the JRC is always policy-based. And specifically in respect of data management, there's a recent communication by the Commission on open data, an engine for innovation, growth and transparent governance. This is quite a recent communication. And there are several issues that are addressed in the communication. 3 are listed here. There's a change to the legislative framework so that information belonging to the Commission can now be reused. In support of that, there's now a European Open Data Portal that you are aware of. And probably more interesting for the future is the extension of the Open Access Initiative in FP7 through into Horizon 2020, which is basically FP8, but with a focus on open access to research data. So there's more emphasis now projects actually preserving and making available the information. Okay, what is the context for data management activities in general? This is my favourite slide ever. It was produced through work that was undertaken by the Publishing Research Consortium in 2010. Now, this was a survey of research, about 4,000 of them, different geographic locations, different disciplines and different organisations. But the trend in terms of ease of access to information as a function of importance of access, the trends without exception are the same. And what you'll see is that, relatively speaking, research is considered that access to data is very important, but it's actually probably the most difficult to access of all sort of information categories. And I would say actually it's probably more important than you can see here, because researchers don't actually get to access that much data that is produced by other groups. So really, this brings home the fact that although we have a lot of technologies, we have a lot of frameworks in place, basically there's still a big issue to address as regards access to data. Engineering materials data, some characteristics about this. Typically it's a rich data model and you're generating low volumes of information. So you perform tests on a test piece. The data model is rich because you have to describe the provenance of the data, you have to describe the material itself, the specimen, the test conditions, as well as the actual results themselves. But in terms of volume, you're typically talking about a few kilobytes, possibly megabytes. It's of inherently high value. Billions of euros are invested in generating materials data, but you would struggle to get hold of any of it. And one key characteristic of the engineering materials community is it has an extensive collection of standards for testing. This is fairly unique to the engineering materials community. These are stable standards that have been developed over probably a period of about a century. The only equipment I can think of outside of the engineering materials community is in life sciences and the protocols that are used there. Characteristics of engineering materials data management. There were initiatives very early on to develop technical frameworks for managing engineering materials data. At ISO, in ASTM in the States, and again more recently at NIST in the States. In the very early days, in the 1980s, ISO 10303 came up to basically an equivalent of UML today, but it didn't catch on. And that's one of the reasons that it hasn't found widespread adoption. As a consequence of this, the engineering materials sector is generally considered to lag about 20 years behind other disciplines in terms of its ability to manage data. But more recently, with the data management renaissance, there have been initiatives which are actually promoting improved data management practices. EPSRC policy framework in the UK and the Materials Journal initiative in the US are examples. And the aim of the work that we're doing here is to develop a data infrastructure for engineering materials. There isn't one. So basically, from supply to delivery, the whole process is fragmented. Without a technical infrastructure, we can't hope to promote effective data preservation practices, inefficient data transfer, fragmented electronic supply chain, and severely restricted opportunities for reuse of information. I think perhaps this is typical of a lot of communities. The engineering materials community has grown to accept this. They can do their work. What's the problem? Well, the problem is that they can probably work a lot more effectively if they had data infrastructure in place. Now, coming from the European Commission, I always like to have a language-based analogy. And it's clear for everybody here what the issue is. Integrating heterogeneous systems is difficult when they all rely on local data formats. So, people are thinking and communicating in the same language here. However, what ICT standards for engineering materials will hopefully do is provide a lingua franca that allows everybody, as shown in the diagram, to think in their own format, but actually to communicate in a common format. Now, what was the platform for undertaking the research? The work was undertaken as CN workshops, and these are particularly effective for developing standards because they are quite agile. 1 or 2 years and the work is complete, compared to conventional standardization process where you have revisions over a 5-year period. They also are very effective insofar as the way the work's undertaken. There is a small group of experts that undertakes the work, and it's steered by a larger group of participants. So typically you'd have 3 or 4 technical experts undertaking the development of ICT standards, and this would be approved and reviewed by a group of, say, 30, 40 or 50 people from the engineering materials community. We undertook the work in 3 basic strands: technical, business analysis, and standardization. Technical approach, technically this was going to be the easiest part of the problem, because in the past we've already seen that we can deliver technical solutions. The issue is getting the community to adopt those solutions. So really the other 2 strands were concerned with engaging the community and and actually promoting the long-term use and adoption of the standards themselves. And to date we've had 2 CEN workshops, one on the viability of standards compliant data formats, and one which is ongoing now on transition to electronic reporting. As I mentioned before, we have a vast collection of standards for materials testing, conventional standards in the original materials community. And what we wanted to do was leverage the inherent value. This has been developed by experts over decades. And what we tried to do here, what the aim was to derive the formats from these documentary standards. So we chose an existing widely used standard for tensile testing. We chose a business case that looked at the transition to electronic reporting, and then conventional standardization organizations haven't really got to grips with modern publishing processes, so we looked into assigning HTTP URIs, and we looked at opening up dialogue with the potential owning groups of the standards that we were going to develop. The results of that workshop were that, as we knew already, conventional documentary testing standards connect to software specifications because basically they provide all the terminology that is relevant to the particular data model that you're interested in, and also they define the rules and relationships so you can implement technical specifications. Working within the scope of documentary standards is particularly effective because you're already working with the stakeholder. They already use the conventional standards, so we can anticipate that they're amenable to using standards that are derived from those conventional standards. There was an interesting but cautious response from the standardization of business sectors. CEN is now looking into a DOI-based approach to assigning HTTP URIs. Conventional standard bodies are a little bit reticent about the extra work they have to undertake because their work is voluntary and it's just adds overhead. And then finally, where large organisations already have invested in solutions internally, basically this is a disruptive technology which is going to cause short-term pain for them. Okay, I've got long list, so the next one. There were a couple of key recommendations that came out of that first workshop. One is to develop a standards-based architecture for representing engineering materials, because what we focused on was the test data. And the other thing was to undertake any reporting proof of concept. And this is being undertaken in the scope of a CEN workshop with Sarah's. We're building on work that's been undertaken previously, so what we want to do is develop a conceptual model. From this conceptual model, we'll develop a vocabulary which is consistent, and then derive a UML representation, and then from that we'll have some different technical implementations, XML, RDF, and others. And in the business case, where we want to investigate the transition to electronic reporting, this is basically what we have at the moment. Typically we have a paper-based or PDF document, and what we want to do is translate this into an electronic format. The first thing that we do is we develop an ICT standard which is equivalent to the reporting standard that exists. Then we use the ICT standards for representing test data, which was the scope of the original project, and for representing materials data. This is the materials data in the background here. And then there are some parts of the certificate which are clearly due to related to approval and authorization, so we would use these signed. So these are the technologies that we intend to use. And this is the business process that we're interested in intervening in with the electronic reporting. So the supplier produces material, sends it to a test house, they get the information back, they get a materials report as well, and this goes to the original equipment manufacturer. On the left-hand side here we see the ICT standards that we're interested in using. We already have the standards for the test material, what we did are the standards for representing the material. Then what we want to do is also use the e-invoicing and digital signing technologies for the actual reports themselves. And finally, there's a recognition that unless we address the concerns of industry and standardization bodies, we're going to fail, as previous efforts have done. And to overcome this, perhaps where large organizations have in-house solutions and best practices, we should be encouraging their participation in the work so that the standards are aligned with their existing standards. And we need to engage the standards bodies so that what we deliver has long-term prospects. Yeah,